Recently, Nobel Prize winner Adam Riess revealed that we may have gotten the universe completely wrong, and he's not the only one. Following the recent discoveries by the James Webb Space Telescope, many renowned scientists are now saying that the universe is far stranger than we previously thought. For decades, we've told ourselves a story about how the universe works. It's called the Standard Model of Cosmology, and it has been the bedrock of our understanding for a generation. But now, the most powerful telescope ever built is sending back images from the dawn of time that are creating a storm in the field of astronomy. A stark warning is echoing through the halls of science. The impossibly massive galaxies and giant black holes appearing in the infant universe are not just anomalies. They are evidence that our entire model of reality might be fundamentally wrong. This latest discovery is not just surprising, it's deeply unsettling. What we are witnessing is a potential revolution in cosmology. To understand why these new discoveries are so terrifying, we first need to look at the theory they threaten. It's called Lambda CDM. The lambda stands for dark energy, a mysterious force causing the universe to expand faster and faster. The CDM stands for cold dark matter, an invisible substance that acts as the cosmic scaffold for building galaxies. For years, this model has been wildly successful. It's an elegant theory that explains nearly everything we see, from the faint afterglow of the Big Bang to the vast web of galaxies across the cosmos. Scientists previously believed that with this model, they understood how the universe looked in its early days. It predicted that after the Big Bang, matter would slowly clump together. Small clouds of gas would merge, forming the first small stars and galaxies. Then, over billions of years, these small galaxies would grow into the grand spirals we see today, like our own Milky Way. This model has been tested and refined, even earning Nobel Prizes for its architects. It painted a picture of a universe that was understandable and orderly, a story that, until very recently, almost everyone believed. But every good story has a plot twist. And in cosmology, the first sign of trouble had been brewing for years, long before Webb opened its golden eye. The first major crack in our perfect model is a problem of maddening simplicity, known as the Hubble Tension. There are two primary ways to measure how fast the universe is expanding today, a value known as the Hubble constant. The problem is, they give two different answers. The first method is like looking at a car's speedometer. Astronomers do this by observing pulsating stars called Cepheid variables and exploding stars called Type 1a supernovae. By comparing how bright they appear to how bright they should be, we can calculate their distance. When we do this, we get a Hubble constant of about 73 kilometers per second per megaparsec. The second method is like using the car's trip computer to calculate its current speed from the beginning of its journey. Astronomers do this by studying the cosmic microwave background, the fossil light from just 380,000 years after the Big Bang. By feeding this information into our trusted Lambda CDM model, we can predict what the expansion rate should be today. This method gives an answer of around 67. For years, scientists hoped this was just a mistake. But as our measurements got more and more precise, the gap widened. It's a 5 sigma discrepancy, which in physics means there's only a 1 in 3.5 million chance this is a random fluke. This stubborn disagreement became the biggest crisis in cosmology. The community was divided, waiting for a new, powerful detective that could settle the debate once and for all. However, everything changed when the James Webb Space Telescope started its science operations. Launched on Christmas Day 2021, it is a marvel of engineering, 100 times more powerful than Hubble. It was designed to look deeper into space and further back in time than ever before. In the context of the Hubble tension, Webb was supposed to be the final arbiter. It would remeasure the local universe with unprecedented accuracy, leaving no room for doubt. It would either prove the measurement of 73 was correct, forcing a rewrite of physics, or it would find an error, restoring faith in the Standard Model. But as Webb began to send back its first images, it did something no one expected. It didn't just investigate the old crisis, it uncovered a host of new ones. Looking over 13 billion years into the past, it started finding things that, according to our perfect model, simply should not exist. The super detective, brought in to solve one mystery, had just stumbled upon a scene of far stranger cosmic crimes. The first pieces of shocking evidence came in the form of galaxies. Webb's deep fields revealed galaxies from just 300 to 500 million years after the Big Bang that were far too massive and far too mature. According to Lambda CDM, galaxies at this stage should be small and chaotic. Instead, Webb was finding galaxies that looked like teenagers, nicknamed universe breakers because their existence threatened to shatter our cosmic timelines. Then came the black holes. Webb started detecting supermassive black holes at the hearts of these ancient galaxies, monsters millions or even a billion times the mass of our Sun. The problem is, black holes are supposed to grow slowly. Finding such behemoths so early is like finding a fully grown redwood tree 1 year after planting the seed. It defies the known laws of growth. Perhaps most stunningly, Webb found a galaxy called Jade's GSZ 13-1, seen just 330 million years after the Big Bang, already blowing a massive bubble of transparent gas around itself. It was ending the cosmic dark ages all on its own, hundreds of millions of years ahead of schedule. No one had predicted this would happen so early. But wait, while Webb was uncovering this zoo of impossible early objects, another project dropped a bombshell. The Dark Energy Spectroscopic Instrument created the largest 3D map of the universe ever made, and its latest results, released in 2025, hinted at something profound. Their measurements challenged the idea that dark energy is a constant, finding evidence that it may be evolving over time with a statistical significance of 4.2 sigma. This discovery challenges one of the core assumptions of the standard cosmological model. So now we have a paradox. Our best local measurements keep screaming 73. Our best maps of the large-scale universe are hinting that the rules themselves might be changing. The crisis hasn't been solved. It has become deeper and stranger. The evidence no longer points to a simple error. It points towards something being wrong with our fundamental assumptions. With each new discovery, scientists are uncovering puzzles that raise serious questions. One line of evidence provides a stark counterpoint. The Kilo-degree survey completed its own map of the universe, and their final analysis, published in March 2025, concluded that their data are perfectly consistent with the standard Lambda CDM model. This deepens the mystery, suggesting the crisis might depend on how you look at the universe. The universe is giving us contradictory answers. This has forced scientists to seriously consider a radical new prime suspect. Maybe dark energy is not a constant. In our standard model, lambda is a fixed, unchanging energy. But what if it evolves? This idea is known as dynamical dark energy. This is exactly what the DESI results are hinting at. An evolving dark energy could potentially resolve the Hubble tension by reconciling the measurements from the early and late universe. It would mean the disagreement isn't a conflict in measurement, but a true reflection of a changing cosmos. If this is true, the implications are profound. It would mean our fate is not sealed. A universe with evolving dark energy could have a much more dramatic future, from a big crunch to a big rip that tears atoms apart. The anomalies seen by Webb, the impossibly massive galaxies and black holes, also add fuel to this fire. Their existence hints that the cosmos may hold far more surprises than we ever imagined. Some scientists are even exploring alternative theories, from new properties of dark matter to modified theories of gravity. So, have we gotten the universe all wrong? Perhaps not all wrong, but our simple, elegant story is showing its age. The combined onslaught of evidence from Webb and surveys like the Dark Energy Spectroscopic Instrument has moved us from a crisis to a genuine revolution. We are in a state of profound and exciting confusion. The universe appears to be expanding too fast nearby, while its fundamental energy might be changing over cosmic time. At the dawn of time, galaxies and black holes grew up way too fast, breaking our models. And yet, some of our best maps show the standard model still holds up. These are not signs of failure. They are the birth pangs of a new understanding. A growing number of researchers are now beginning to suggest that it's as if we are seeing an entirely different universe, one filled with enormous galaxies and mysterious cosmic structures that defy everything our current theories predict. We thought we were nearing the end of our map of the universe. It turns out we may have just discovered entire new continents. The only thing we know for sure is that the universe is far stranger, more complex, and more magnificent than we ever dared to imagine. And the journey to understand it has only just begun.